In this video, we'll be talking a bit about solving linear inequalities. The basic rules for solving inequalities are the same. Here are the three big things we need to keep in mind. The first is that addition and subtraction do not change inequalities. So, for example, if A is less than B, then that automatically tells us that A plus C is less than B plus C, no matter what A, B, and C are in this case. We just need A to be less than B. In a similar way, multiplying and dividing by positive numbers doesn't change inequality as well. That is, if C is a constant greater than 0 and A is still less than B, then AC is still less than BC. So you see here that multiplying by C does not change the inequality between A and B, just like it didn't change with the addition. However, we do have to be very careful when multiplying or dividing by negative numbers, because if C is less than 0, aka negative, and A is less than B, then AC is now greater than BC, so it flips the inequality. Now, the simplest type of inequality to solve is a linear inequality in one variable. For example, this would be a linear inequality in one variable because both of these are linear expressions, similar to a linear equation. To solve this, let's go through and use the rules that we talked about before. So, solution. We have here that 5x, so let's go ahead and write down what we are given. Always a good idea. Let's subtract 3x from both sides. When we do that, again, we're adding or subtracting. It doesn't change the inequality. So we have 2x here. We have no x's over there. We can also take 7 to the other side. So let's add 7 to this side. By doing that, we end up with 16 over there. So, again, the inequality did not change, so we have 2x is greater than 16. Now we want to divide both sides by 2. Whenever you divide or multiply, you need to ask yourself, is the number I'm multiplying or dividing by positive or negative? Because it's positive, it does not change the sign. However, if it were negative, it would. So, our solution set, graphing our solution set, so this is our solution set, and graphing it, that would look like the following. This is 16. We know that we're getting x greater than 16, so we leave an open circle there and shade in this area. And now it's time to have you try an example, so go ahead and try to solve this inequality and graph the solution set. On the count of 3, I'll reveal one of the solutions to it. 1, 2, 3. So this is one solution for the problem. However, there is another way you could do this problem, so consider this way of doing things. 1, 2, 3. So in considering this solution, so before I went ahead and made sure I kept everything positive, but in this solution I went ahead and subtracted 7x from both sides instead of 2x from both sides, thus canceling the 7x on this side. But then I get a negative here and a negative here. Well, I decide I'm going to divide by my negative, and I'll get positive 2 over here because a negative divided by a negative is a positive. On this side it cancels out the 5, but I have to flip my sign because I divided by a negative number. If I hadn't flipped my sign, I would have gotten a different answer, which wouldn't make sense. So that's at least some justification of why it's important to remember to flip the sign. If you'd like some more practice in working with linear inequalities, be sure to see page A64 and work problems number 13 and through 30 of the textbook. In our next video, we'll talk about solving double inequalities.